All right, so we're going to take a look at inequalities. Right now, an inequality, is different than an equality in the sense where, let's say, we have this statement, right? X is equal to 3. All right, now it's very clear, right? X is 3, cannot be anything else, right? 3 is the only value that satisfies this equality, right? But when we have something like, let's say, X is less than 3, right? Well, then, in this case, we have, well, 3 actually doesn't even work in this case, right? 3 is not less than 3, right? But 2 would work, 1, 0, 1/2, right, etc., right? What we could see here is there are actually an infinite number of values, right? Where here, if we think of it in terms of a number line, this is 0, 1, 2, 3. We would just have the value of 3 satisfies this equality. Now, for something like this, X is less than 3. Now, I'm going to use an open circle since now this signifies that my solution does not include 3. Now, less than, I'm going to shade in everything to the left, right? So that means any of these values going on to infinity would satisfy this equality, right? 0, -1, -5,000. Right, now the way I would write this in interval notation, we have, since it's unbounded on the left, right, and then here it's bounded by 3, right? I use parentheses to signify that it is not including 3. We would use brackets if we want to say that it does include the endpoint, right? Infinity always has an open bracket because infinity is not really a number, it's more like an idea. Right, now, in terms of our inequalities, we have 4 different types of inequalities that we're going to look out for. Right, we've seen one already, right, where now I'm going to generalize here. X less than A, right, where A is just some real number, right, and we've seen already what this looks like. I'll use a straight edge to make sure this is just a little bit neater, right? So let's say A is some real number, right? Some real value, right? Let's say it's somewhere here, right? Given that it's strictly less than, we use the open circle, and then we shade everything to the left. Now, if I wanted to say X greater than A, right? So here, let's say A was somewhere here. Again, still not inclusive of A, strictly greater than. And then we have here to the right. Okay, now the other 2 sets of inequalities that we might encounter is something that looks like this, where we have the bar under the less than equal. Less than, and this signifies X is less than or equal to A. Now, in terms of our graph, we have one, actually, excuse me, let me go back up here. Before we move on, my apologies here. Let's write it in interval notation, right? And again, the interval notation, once we have the number line, easy to write. This would be from, it's unbounded on the left, so from negative infinity to A. And over here we have from A to infinity, so it's bounded on the left by A, but unbounded on the right. And that's positive infinity. Okay, so that's how we would write it with interval notation. All right, now back to this one, right? Strictly less than or equal to A. So one thing changes from our graph above. Let me change colors here. Right, let's say if this was A, right, less than or equal to A. Now we're gonna fill in the circle. All right, and less than is all the values to the left of A. Okay, so that's the one change, right? The filling into the circle is it is telling me that it is now inclusive of A as well, right? So, well, as before, we have less than A, X less than A. A made this a false statement, right? Which is why we don't include it, right? A is not less than A. But now, less than or equal to A, now we could say, right, is A less than or equal to A? Well, it's not less than, but it is equal, right? It satisfies one of those conditions, so now we include it. And in terms of our interval notation, right, again, unbounded on the left, so from negative infinity, and on the right, we have A. All right, so we have those square brackets. All right, so now the fourth one here, x greater than or equal to A. So if A is here, again, the only change here is that now we are inclusive of A. And greater than or equal to is values to the right. Okay, so now in interval notation, we have A bounded on the left, right, inclusive of A, and then unbounded on the right, so going to infinity. All right. Okay, so those are the four types of inequalities and how we can represent those on a number line and using interval notation. Now let's take a look at some inequalities that we'll be solving. We'll look at two examples here. Right, the first one, let's say R. So solve the following inequality. Graph the solution and write using interval notation. Okay, so here, what I'm going to do here is I would like to get it in one of these forms, right? So I want to essentially simplify my inequality so it looks like this, where I have x and then less than, greater than, or less than equal to, greater than or equal to some number, some real number. Okay, so in order to do that, we have to add 1/3 here. So I'm going to add 1/3 to both sides. All right, now here, 7/12, I'm going to rewrite 1/3 as 4/12. Right, common denominator 12 multiplied by 4 over 4. Right, just do that in one step. Right away we could see, okay, this is R is less than or equal to 11 over 12. Okay. All right. So we've solved the inequality. Now let me represent the solution, how they asked us to do this here. So using interval notation, excuse me, let's do the graph first. Right, so let's say zeros here. Let's call this 1. 11/12 is a little bit less than 1, so I'm going to call this here 11/12. Right. Again, just kind of estimating where it is, right? Excuse me, less than or equal to. So we fill in 11/12. And we're looking for values less than as well. So I fill this in. So values to the left using interval notation. It's unbounded on the left, so negative infinity, up to and including 11/12. Right, so it'll look something like this. Okay. All right, so let's do another example here. So we're gonna do the same thing, where I'm gonna ask to solve the following inequality. graph the solution, and write using interval notation. All right, and here we'll have the inequality is 7p minus 28 greater than 8p plus 3 times p minus 12. Okay, all right, and again, the goal here is the same as before, right? To get it to look something like this. Our variable, some kind of inequality, right, and a number to the right of it, right, some kind of a real number. All right, so this one does look a little more complicated, but don't let that throw you off here. We'll do it step by step, right? The first step here is, well, let's uncomplicate this right here, right? So in getting to this goal, let's undo these. Let's distribute, right? So we'll distribute the 3 to both of these values here. So we'll get all right. And now I see I have 2 like terms, so let me combine these. So 8p plus 3p is 11p, right? We just add the coefficients, minus 36. All right, and now I'm going to subtract 11p from both sides. And here we have negative 4p minus 28 greater than negative 36. All right, now let me add 28 to both sides. And we get negative 4p greater than negative 8. Okay. All right. Now here's something we have not encountered before, and it's something we really have to be careful with. I can add or subtract any value here, right? And it really doesn't affect the inequality, right? Now, it does, my inequality is affected when I divide or multiply by a negative value, okay? So when that does happen, what we have to do is we have to switch around the negative, right? So for example, here, why is that the case? Because we're taking essentially dividing or multiplying by a negative. It's kind of an opposite operation, so it turns everything around, right? So for example, let's say I had this statement, 2 less than 4, right? That value is true, right? If I, let's say, add 10 to both sides, okay? 12 less than 14. Still a true statement, right? If I subtract 15 from both sides, we get negative 3 less than negative 1. Also true. But now let's say I multiply both sides of the inequality by negative 2. Then we get 6 less than 2. And that is not correct, right? So this multiplication by a negative, right? Essentially think of the opposite. So what needs to happen is if instead of once multiplying the negative, we also flip the inequality, now we get a true statement. 6 is in fact greater than 1. Okay, so seeing this now and going back to our problem, if I'm going to divide by negative 4, p is now less than, instead of greater than, 2. All right. Okay, so now to wrap this problem up, let's graph the solution. So 0, 1, 2, strictly open, and less than, so everything to the right. So that'll be graph of the number line in interval notation. We get from negative infinity to 2. All right, thank you.